There you go. So one book sitting on the desk, another book sitting on top of it, gives you the mass of both books, and tells you that the books are in equilibrium. Wants you to find the normal force acting on the first book. So step one, draw the object. So in this case, we're going to draw my desk, and here's the first book and the second book on top of it. Okay. Once I've done that, then I'm going to draw my vertical forces, which are up and down. So the forces we've talked about are normal force, net or applied force, gravity, force of gravity, friction, tension, and air resistance. So there's no air resistance. It's not in free fall. There's no tension. There's no ropes. There's no applied force. There's no object pushing on these objects, although you'll see there is one in just a second. But we'll kind of play that around in a different way. And then there is going to be normal force because there is a support force keeping the book from falling, and there is going to be gravity. Won't be any friction because there's no motion or attempted motion. So what are the forces acting on this bottom book? Because that's what we're worried about. We're worried about this bottom book. So there's a force of gravity pulling it down. There's a normal force from the table pushing up on it. It's the third force that's kind of tricky, and that's trying to figure out what's going on with this other book that's on top of it. So there's two ways to think about it, and I'll tell you kind of the best way to think about it. So the best way to think about it is that it's an applied force. It's a force from another object onto that object. But it might be easier to think of it as another gravity force. So I'm going to write FA equals FG. Now I'm going to call this G2 and this G1 so I don't get it confused. But it is an applied force, but the value of the applied force is equal to the force of gravity. Okay? So step 3, draw the horizontal forces. There aren't any here. Step 4, draw the direction of the acceleration or the net force. Well, the problem said it was equilibrium, so that means the net force is 0. Okay, 5, write the values if known for the forces in your diagram. Solve for the force of gravity for any of these. So we're solving for normal force. We don't know what that is. That's what the problem's asking for. Okay, and then it says to solve for the force of gravity. So I got 2 gravity forces. I got gravity acting on book 1 and the applied force because of the gravity acting from book 2. So the way I find that is by doing Fg equals mg. Okay, so the first one would be the mass of object 1, which is 5, times the acceleration due to gravity, which is 9.8, gives me 49 for the first one. Okay, the second book is going to be the mass of object 2 times g, which is going to be 2 times 9.8, which is 19.6. Okay, so that's step 5 done. And lastly, find the net force or find the missing forces. So I know what the net force is, it's 0. So now I just need to find the missing forces. So the way I go about doing this is by doing F net equals force 1 plus force 2 plus whatever. And this is just the definition of net force. Net force is what you get when you add together all the forces. Okay, so what are the forces and what is the net force? Well, the net force is 0. F1 will be my first force. Well, which is my first one? It doesn't matter. Okay, gravity, 49. Now it's downward. It's opposite of my normal direction, which would be up. So it's going to be a negative 49. plus my second force. We'll make normal my second force. That's fine. Plus my third force, which in this case is gravity on the second book, which is a negative 19.6. And again, if you're wondering why it's negative, even though these are positive, I'm looking at the directions in my diagram. Okay, so 0 equals, this would be negative, when you combine these two, negative 68.6 plus normal. I would then add the 68.6 to both sides. And that's where my answer comes in. So the trickiest part of that problem is figuring out how the second book factors in. But other than that, it's the same kind of deal we've been doing. Figure out what forces you can, combine them together, and then either use the net force to find the missing force or use the forces to find the missing net force, whichever one you have to do. Okay. If we got more questions, I'm more than happy to come back to this. If anyone wants to see two, I'm more than happy to come back at this at the end. But I want to wait until the end to see if you have any questions so that we can get through the notes here and not take too long with these. All right.